Hi, everyone. I am Alejandro Mercado. Very honored to be here sharing this talk. The name of my talk is From COBOL to Node with DevOps. So let's start. Oops. Sorry about that. A little bit about me. I am a developer, adding DevOps tools under my belt, also text writer, and sometimes I am a speaker. So COBOL, maybe a lot of people, especially young people, doesn't know what COBOL is. So COBOL is this programming, very old, I can say, programming language. It was designed in 1959. So you can picture how old it is. It's older than me. But the question here is that we still are running a lot of COBOL code. So that's why it is important, and that's the intention of this talk, to see what's going on with this code. So we are trying to not to migrate the code, but just to extend this COBOL code. So I can say that COBOL code is heavily used in the financial sector. We have a lot of code in running in banks, in insurance companies, also in the ATMs machines. They are still running COBOL. So wow, take a look at this picture. It's like, the report. You can see the date at the bottom of this image. So well, that was the first specification of the common business oriental language, like COBOL. So more than 60 years old, so still a lot of COBOL code, but a lot, especially in the financial sector, as I said. So take a look at this infography. So wow, this is surprising. So this is actually a surprise, because this software engineering research center claim that there are more than 200 times more COBOL transactions than Google searches worldwide. So wow, this is a lot. So why we still have a lot of COBOL code? So there are a lot of reasons, because of course the first one is COBOL is so robust, and I can say that it's also a survivor. So it's been adapting to business changes for decades. So it really knows the ropes when it comes to keeping things running. So I can say it's a very stable technological stack. Besides of that, COBOL is very intuitive, and it's easy to learn because of these English-like structural components. And it has been ported to virtually every hardware platform. So it even integrates with next generation of modern languages like C#, Java, and of course JavaScript, and of course therefor node.js. So is object-oriented? No, it's not, but COBOL is pretty intuitive. So as I said, we have been porting COBOL to use the modern tools like Visual Studio Code. So you can run your COBOL programs, with Visual Studio Code. You just have to download the plugin. There is also a lot of plugins available. So the advantage of using, Visual Studio Code with this plugin is that you are going to have the aid, the help that you currently have with other languages, like the IntelliSense, Goto functions, over the color syntax. It's already there. So it doesn't feel like very old, because we have been adapting this COBOL to our modern tools. So you can take a look of this COBOL code running inside Visual Studio Code. So it's practically the same. Even we can use containers that we're going to see in a moment. So yeah, we can have the IntelliSense, breadcrumbs, go to features, go to pick, color syntax. It doesn't feel that old. So I think that we are adjusting the experience. Yeah, to have a pretty good experience. I mean, a developer experience for new developers. Maybe you are asking, how can I compile a COBOL program? But the first option is just to download there is this COBOL, free COBOL compiler. So you can just download, and that's it. It's pretty straightforward. Or maybe you can run it in the cloud. Well, maybe, as you may know, we have these mainframes. A mainframe is not other thing like a server, but at that time, more than 20 years ago, we have these mainframes, very big machines. So it's just a computer used primarily by very large organizations for critical applications. I can say that this was the primary intention is to run mission critical systems. So like bulk data processing for tasks such as censuses, transactions, I mean monetary transactions, consumer statistics, enterprise resource planning, and well, a lot of large scale transaction processing. So also the term mainframe first describe the physical characteristics of early systems, so then it can be best to be used to describe a style of operation, applications, and operation system facilities. So, well, this is a not so old picture of a mainframe. It's an IBM mainframe. I think it's the Zeta series. So, now we have the cloud. The cloud is for everything. So maybe you want to run, maybe you don't want to install anything in your computer. So, well, you have this option to run COBOL in the IBM cloud. So it's like just follow the instructions, registration. And we have this project, it's the Open Mainframe project. It runs under the Linux Foundation umbrella. So you can take a look of several resources like training, and well, also they have an option to run your applications on the mainframe on the cloud. So maybe you want to take a look. And of course, we have to talk a little bit Docker containers. It is very important, and it's an important part of this talk, because Docker, I think that it was like 5 years ago, the Docker supported the mainframes. I mean, so now you can run a COBOL program inside a container. So, well, that was a huge fact, because it opens the possibility of doing a lot of of having another style for architectures that we are going to review in a bit. So because of COVID-19, maybe you heard about that. During the COVID-19 pandemic, there has been a sharp increase in demand of COBOL programmers because, well, they are now we can still see a lot of government federal systems running with COBOL. So the problem is that maybe you are wondering, so why, if COBOL is so robust and a survivor and a pretty good language, and we have these modern tools running inside Visual Studio Code, why the need of migrating COBOL code? Well, as a matter of fact, the scarcity of COBOL programmers has led to increases interest in we are running out of COBOL programmers, so that's the main reason. So a lot of, I can say, young people don't want to learn COBOL because they feel that it's obsolete. So they prefer to learn, I don't know, very modern languages like Go or Rust. But actually, that's the problem, and it's not a problem in COBOL itself. It's a problem about the demand of these COBOL programmers. So that's the problem. So we have we were working for this company that wanted just to make a proof of concept so we can help to solve this problem. So as we all know, we can find a lot of JavaScript programmers out there. So that's why we made this proof of concept to see if we can extend COBOL code. So the idea was not to get rid, it was not to eliminate COBOL code, but extend and adapt it. I have to say that pretty clear. And just because of that, but because we can't find enough COBOL programmers to maintain and to scale our current COBOL systems. No, so take a look at this image. It's fun because it's true. So well, yeah, if you take a look at the job boards, you can find a lot of COBOL vacancies. So well, to learn COBOL nowadays is not a bad idea. So well, we have this problem. So all this situation about COBOL running on a monolith. So monoliths versus microservices, are different styles of or architectures, software architectures, I can say. So a monolith can be considered an architectural style or a software development pattern or anti-pattern if you view it negatively. So a software system is called monolithic if it has a monolithic architecture in which functionality distinguishably aspects, for example, data input and output, data processing, error handling, and the user interface are all interwoven, rather than not containing architecturally separate components, as we are seeing nowadays. So COBOL was made to perform all kinds of operations in one block, but we have learned through the years that modularity is the key to success. So I don't want to go into this discussion because, you know, someone can say, no, it's not that true. Monoliths can run faster, can perform well, but you know, the microservices is like we are still learning a lot of microservices of how to correctly implement microservice, but they offer some advantages and of course some disadvantages. So in this moment, I have to talk a little about that DevOps because, well, it's the key ingredient of this talk. You know, this graphic about DevOps is everywhere. It's very famous. You know, DevOps is this whole movement or culture to improve the software development life cycle. So the idea is not new. It's how can we make better software and faster? So that's it. So just like just to say, like a very basic definition is that DevOps is a set of practices that combine software development and IT operations. But to be honest, I don't like this definition. It's very simple. It's not that easy. It's not like just to sit together, developers and sysadmins. No, of course it's not. I have a couple of more definitions that I think the third one is like a better one. So I would like to say that DevOps is this culture where people, regardless of title or background, work together to imagine, develop, deploy, and operate the systems. I think this is a better definition. So DevOps is cloud native. So yeah, when we talk about DevOps, in terms of this agility, we are talking about cloud native components. So cloud native DevOps is a way to increase the velocity of your business and a method to structure your teams to take advantage of the automation and scalability that cloud native technology like containers, you know, Docker, and of course Kubernetes offer. So that's very important. So what we did, yeah, of course, we like JavaScript. So that's what the idea. How can we extend? As I said, the idea was not to get rid of the COBOL, existing COBOL code. So the idea is just to try to cover new features, to extend our base code, but in this case using our dear friend JavaScript. So yeah, the first approach, you know, is to make microservices. But how can we make microservice against a monolith, a COBOL monolith? And I am not going to talk about the advantage of Node.js because, well, there is a lot of information out there about Node.js and why we like Node. So, you know, it's an event-driven, it's single-threaded, it's fast and highly scalable, you know, just to name a few advantages. And of course, we can find a lot of backend frameworks. So actually, there is this, it's not a framework, it's a toolkit that the name is Seneca. Seneca is a microservices toolkit for Node.js that, so of course we can use another backend framework like Express, Nest, Meteor, Sails, Adonis. But I mean, this was not like the main problem to solve. This was one of the less concerns that we had. So yeah, as the song, you know, this Beatles song. said, with a little help from my friends and my friends Docker and Kubernetes. So yeah. So because we have containers and we have the orchestration of this container, the integration of this monolith, or the extension was possible. So there is this node.js-COBOL. If you are a little curious, and you can do a fast search on Google, and there is code plugin for Node.js, and so it's like very interesting. But well, also there's the GitHub repo. You can take a look and make the experiment. So running Node.js inside a COBOL program feels pretty weird. So well, this was like just a first approach, but we know that it was not the correct solution, because this is cute, but really it's just like a toy. It just runs Node as a shell command. So it was not intended to put it on production. So we have the path. The path was pretty clear, and we are talking about the evolution of software deployment. So from physical servers, virtual machines, containers, to serverless. So that was the path. It was like, we have the idea, but the implementation was there. So the transformation is about that. So we have these monolithic applications that implements all features in a single code base with a database for all data. So that was the current, or that was the state. So microservices divide a large program into multiple smaller independent services. So we have this microservice new style. So it was not just like a technical radical change, but like a mindset that we had to, that was just a proof of concept to gain credibility. But we for sure know that microservices have these multiple code bases, and each service manages its own data. So it was an advantage. It is an advantage. So the advantage or pros of microservices architectures, well, they are easier to develop and maintain. So they reduce the risk when deploying new versions. Services can scale independently to optimize use of infrastructure. It's faster to innovate and add new features. Can use different languages and frameworks for different services, like of course Node, and we can choose the runtime appropriate to each service. So we have these very clear advantages of doing a microservices architecture. So of course we have the other side, of the coin. We need to maintain backward compatibility with clients as the microservices evolves. Having a lot of microservices can lead to some troubles too. We have an increased complexity when communicating between services, so we have to handle that. Increased latency across service boundaries, concerns about securing inter-service traffic, multiple deployments, and need to ensure that you don't break clients as versions change. So it's not just honey on plates. There is this other side that you must consider when implementing this. So the first approach was to run this monolith in a single virtual machine. It's something like that you can see in the picture. So but the problem, well, we are not really solving anything. We have this low isolation and still tied to an operation system. So, well, but it was a step to what we wanted to approach. So the second step was to run these microservices in multiple virtual machines. So it was like, well, now we can scale, but they still have this redundant operation system, you know. So I still share a lot of problems. So, well, running microservices and multiple containers. So, yeah, this was a better approach because we don't have to virtualize the entire machine, just the user space, and of course, they are lightweight. So it's that's why I have this other slide about the when Docker announces the support for COBOL, you know, because they have this special Linux distro. So well, a couple of years ago we can run this distro inside our container. So well, this was a key moment. So containers are lightweight, standalone, resource efficient, portable, and in executable packages. So that was the best approach. So we can run our node in separate microservices, extending the existing code base. So it was the way to go. And of course, you know, this happened a lot. Maybe this is typical developer phrase. It works on my machine. So developers like containers. Yes, of course, we do, because a lot of developers, I think, and don't worry about the underlying infrastructure, and solve this works on my machine problem. So we can deploy fast and easy. So we are solving this problem about the scarcity of COBOL programmers, migrating the whole architecture to microservice, but still in respect of this. I mean, it's still working. It works, and it works well. So we don't want to touch it. But we need to extend this functionality, especially you can think about, you know, web user interfaces or mobile. So we need to extend or to give extra functionality. So because we have microservices, we still can, you know, microservices running in containers, using Kubernetes to orchestrate them. So we can make this possible. So as a developer, I don't care too much about the underlying infrastructure, or I don't want to take care a lot of time dealing with the, you know, the administration system, security issues, patch, etc., etc. So well, we can make our deployment pretty easily with these images. So yeah, that's about DevOps. It's about this agility that we want to add to this very old stacks like this COBOL. So yeah, to deploy having these microservices in containers, we can deploy fast and easy. So it was like a very good experiment, I can say. So now we can develop in our, well, not just JavaScript, in any languages that extends COBOL, or even you can still program in COBOL, but based in containers and in microservices. So that is a huge advantage and a new approach to these old systems. So yeah, so we have happy developers running all an important code. So that's all that I got. I'm going to be around here. If you have any question, there is my email and my Twitter. So thank you very much. Bye-bye.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.